So let's do some graphing acceleration. So we need to review some of this stuff that we did for D versus T and V versus T graphs. All of it's the same as what we did before. We're just adding on acceleration. So for a D versus T graph, slope represents speed. Y value represents your distance. Of course, it's velocity or displacement too, but I just don't want to write all that out. Moving forward is a positive slope, because slope is speed. Positive slope would be moving forwards. Moving backwards is a negative slope, negative speed, negative slope. And stopped is a flat line. If I'm moving faster, it's going to be steep. So this is fast. And then moving slower is shallower, so this is slow. Okay. Still need to know how to do that for what we're doing today. For V versus T, slope represents acceleration. Your Y value represents your speed. Area under the graph represents your distance. And moving forward, so we draw these guys like this, with this being 0 right here. So moving forwards is above the x-axis. Moving backwards is below the x-axis. And stopped is when you're at the x-axis like that. If I'm moving faster, it's going to be this. This is fast. And if I'm moving slower, it's going to be closer to the x-axis, like that. Okay, so that's what we did before. Still need to know all that. So, what represents speed on a D versus T graph? Well, that's our slope, right? So, if I'm accelerating, I'm increasing my speed. So what would it look like if my speed increased? Well, stopped is a flat line, and a really steep line means I'm going fast. So what's going to happen is we're going to have a curve to our line, and our line is going to get steeper and steeper and steeper. Right? What would it look like if I decrease my speed? Well, I'm going to start off with, I'm not going to start off with a flat line. I'm going to start off going fast. There we go. Let's try this again. So if my speed decreased, well, I'm going to have a super steep speed right here, right? Super steep line, and then I'm going to go to a shallow line or a flat line. So it's going to curve like that, and it's going to slow down. So this is flat to steep, and this is steep to flat. And this is both if I'm going forwards. Now, what's it going to look like if I increase my speed and I go backwards, right? So both of these are positive slopes, right? They go upwards. Well, I want to go downwards. I want the general trend of my graph to be like that. And if I want to increase my speed, then I'm going to want to go flat to start, and I'm going to want to go to steep. So I'm going to go curved line, flat to steep, and it's going to be a curved line that looks like that. If I decrease my speed going backwards, again, backwards means my slope looks like that, but I want to go from a steep line to a flat line. So it's going to curve, and it's going to go like that. Excuse my terrible drawings. Well, what about on an acceleration versus time, or velocity versus time graph? What does speed represent? Well, that's our Y value. So if we want to increase our speed, we want to increase our Y value. So what that's going to look like is, well, we're going to start off with the Y value that's here, and we're going to end with the Y value that's here. And it's going to be a nice straight line, because speed is our slope is our acceleration. So we want a constant acceleration. We'll always have a constant acceleration. So it's just a flat line that looks like that. If my speed is decreasing, well, I'm going to start with a Y value that's up here. I'm going to end with a Y value up here. My slope is going to be constant. So it's going to look like that. What about if I'm going backwards? Well, what does going backwards look like on a velocity time graph? Well, that means I'm under here, right? So if I want to increase my speed, here is a speed of like -1. Here's -5. So I'm going to go from 1 to 5. Oh, that's my speed increasing on a velocity time graph. What's it going to look like if my speed decreases? Well, if I'm going backwards, I have to be down here. -5. Remember that the negative just means backwards. So this is 5 backwards. This is 1 backwards. So if I'm decreasing my speed, I want to start off at 5 and I want to end up at 1. 5 to 1 is going to be decreasing speed, and it's a flat, sorry, it's a constant slope like that. So it's a straight line. It's not a curved line like with the other one. So remember our moving man simulation. We're going to try them out again, and we're going to use them again. So I'm going to do these as board questions. So with this moving man, what I can do is not only can I make it move, but it'll also graph out what's going on here. So I'm going to do some motions. I'm going to start them off over here. So I'm going to do some motions. I'm going to give him some speeds. And then I want you to try to graph it out. So we're going to do this as a board question. So I'm going to give him 0 speed to start. And we're just going to start off nice and easy. I'm going to give him an acceleration of 2. So no speed to start out. And an acceleration 2. And we're going to hide this up and we're going to play what happens. Okay, that's what he does. So he starts off with a speed of 0. And he increases his speed, increases his speed, increases his speed. And what I would like you to do is I would like you to try to draw a D versus T graph and a V versus T graph just on your own. So pause the video now and try a D versus T graph and a V versus T graph. Okay, so we're going to take a look at what that looks like. Oops, I didn't mean to do that. So if he's just increasing his speed the whole time, let me draw this out for you. So you have to think of what your Y value looks like. So this is actually for both, we should draw them like this. So this is my D versus T, and this is my V versus T. So my Y value for a D versus T graph is where he starts. And he starts off at -10 here. That's his position, right? His position is -10. And the whole time he speeds up. So he starts off with no speed, and we want him to be going steep. So we just have to connect that line with a curve. And this is what my D versus T graph would look like. So if you drew that, awesome job. For my V versus T, we have to think of what the Y value represents. Well, the Y value represents speed. And he starts off with 0 speed. And then he's going fast and he's going forwards the whole time. So it's just going to be a flat line or a steady slope like that. And that's what my V versus T graph is going to look like. So let's try another one. And let's do it a little bit trickier. So let's make him go backwards. So I'm going to start him here at a position of 10. And let's just make him go backwards. So to make him go backwards, we're going to have a negative acceleration. And yeah, let's just try that one out. So we're going to hide these up. Okay, so let's play that back. So he starts off at a position of +10. He's going backwards the entire time, and he's speeding up. He's going faster, 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 until he reaches a position of -10. So I want you to pause the video and try to draw that, just like we did with the last one. Okay, so I'm going to do it here. So he starts off at a position of +10 here, and then he starts off stopped again. So we want a flat line, and then we want him to go steep. So we want our slope to go down like this if we're going backwards. So that would be going backwards. Okay, that's what our graph would look like. Again, we start off at a position of 0, and we want him to be going fast in the end. And we want him to go backwards, so we want to be under the x-axis. So this is what it would look like if he was going backwards. And we can take a look at the graphs that they've graphed for us, right? Just like the one that I drew, and just like the one that I drew there. Okay. So let's try one more, and let's do a tricky one here. So what I'm going to do is, let's start him out over here. And let's give him a negative speed to start. So I'm going to give him a speed of -5. And we're going to give him a positive acceleration of 2 so that he slows down, right? If our velocity and our acceleration are in the opposite direction, then he's going to slow down. So let's take a look at what happens here. Perfect. Okay, let's play that back. So I start him off with a negative speed. So he starts off at a position of -10, but he goes backwards with a negative speed. The whole time he's slowing down until he stops at a position of about 4. He turns around, and then he goes forward. So his acceleration is constant the entire time. So he's slowing down, slowing down, slowing down, slowing down, stops, speeding up, speeding up, speeding up, speeding up. Okay. See if you can draw that out on a distance time graph and a velocity time graph. I'll play it one more time, and after I play it, pause the video and see if you can draw that out. Okay. So slowing down, slowing down, slowing down, stops, speeding up, going forwards, like that. Okay. I'm going to draw this out. Hopefully you've tried this out on your own, because it's very useful to try it on your own. So again, he starts off at a position of +10, but he's going fast and he's going backwards. So I'm going to start off like that. And then he makes it to a position of about +4, and that's where he stops. So this is the first part of it. And then at the end, he's going very fast again, but he's going forwards. So it's going to be a curved U shape. It has to be curved like that. Okay, and then what we do for our V versus T is we think of, well, he starts off at a fast speed, but he's going backwards. So here's a fast speed, and he's going backwards, and at a certain point he stops. So this is when he stops right here. Okay, the acceleration is constant, so it'd be like that. And then he goes forwards, and at the end he's going fast, so I want to be going fast here. And my acceleration doesn't change, right? The acceleration is always constant. So that's what it's going to look like when he's going fast forward. So it's just one constant straight line like that, going from fast backwards to fast forwards, and that's what it would look like. So let's try an example that you could see on a test. What's the object's velocity at 12 seconds? So velocity at 12 seconds, oops. Well, you have to figure out, use those charts, those summary charts that we had. What's velocity on a velocity time graph? Well, that's our y value. Well, that's easy. So I just have to find 12 seconds, which is about here. And then go to my y value, which is 60. So it's going to be 60 meters per second. And that's forwards. And that's it. Okay. Distance traveled in 40 seconds. Well, that's my area under my graph. So what I need to do is I need to find from my 0 line here to my line of best fit. So before, when we did that, they made all nice rectangles, but this line here to my line of best fit doesn't give us a nice rectangle. So if we want to find that area, we have to break it into chunks. So this is area 1, this is area 2. So now I have a triangle that's 10 by 60. I have a rectangle that's 5 by 60. And then I have another triangle that's 15, right? From 15 to 30 is 15 by 60 as well. And then we have to go up to 40. So I go from my 0 line to my line of best fit. So we have to find this area here, which I'm going to call 4. This is 3, this is 4. And this has a base of 10 and a height of 40. Now I won't put in the negative because it's just distance traveled. So what I need to do is I need to find those areas. So I have 1, 2, 3, 4. So 1 is a triangle. So it's base times height divided by 2. So my base was 10 seconds. My height was 60 meters per second. I divide that by 2. That's going to give me 300 meters. My second one is a rectangle, so it's just base times height. My base was 5. My height is 60. I don't divide it by 2. I get 300 meters as well. My third one is a triangle. I said that my base was 15 seconds. My height is still 60 meters per second. I divide it by 2. So that's going to be 450 meters. And my last one, my base was 10 seconds. My height was 40 meters per second. Again, I'm not doing the negative because it's distance. I divide it by 2. That's going to be 200 meters. So to find my total distance traveled, I just add up all those separate distances. 300 plus 300 is 600, 1,050. 1,250 meters is my distance. Okay. The next question asks for displacement after 40 seconds. Well, that's easy. These guys are all positive. This one's negative. So I just have to add in those positives and negatives. So if I do that, this is positive 300 meters. This is positive 300 meters. This is positive 450 meters, and this one is the backwards one, so this is minus 200 meters. So if I add all these up, 300, 600, 1,050 minus 250 is going to be 850 meters. It's positive. Positive means forwards, so that's my total displacement. And the last one, what is the object's acceleration at 8 seconds? Well, to find acceleration, you need to find slope. So right here is 8 seconds. So my acceleration is constant. So I just find the slope of this entire line. So this is 0.1, this is 0.2. I go y2 minus y1 over x2 minus x1. My y2 is 60 meters per second minus 0. My x1 is, or my x2, sorry, is 10 seconds. Minus 0 seconds. 60 divided by 10 is 6 meters per second squared. And acceleration is a vector, so I'd have to add on forwards to that. Okay, this next one here is a board question. So usually what I do in class is this could represent a D versus T graph or a V versus T graph. And I just want to get students to describe what happens or tell me where this is happening. So you'll have to be good on your mouse here because I'll just ask a few questions. So firstly, let's start off with this as a D versus T graph. Okay, so I'm going to ask you, if this was a D versus T graph, where am I moving forwards? Okay, D versus T graph, where am I moving forwards? Pause it. You would be moving forwards anytime you have a positive slope. So you'd be moving forwards at 1, and you'd be moving forwards at 7. Okay, these are both positive slopes, so the one you'd be moving forwards. Okay, for a D versus T graph, so this is question number 2, where am I accelerating? Okay, so pause the video. Where am I accelerating? So the answer is nowhere. You need a curved line to be accelerating. So you aren't accelerating anywhere on this because you don't have any curved lines. Okay. If this is a D versus T graph, this will be the last question. Where am I stopped? Okay, so pause it. Where am I stopped? Well, stopped is a flat line, so that's going to be 2, and that's going to be 6. So 2 and 6. Okay, so let's change this from a D versus T graph to a V versus T graph, and I'll ask you some questions about it. Okay, so if this was a V versus T graph, where am I moving backwards? So pause it, see if you can figure out where you're moving backwards. So you are moving backwards anywhere you're below the x-axis. So this whole section here is backwards. So you're moving backwards 5, 6, and 7. Okay. Next question, where am I slowing down? So pause the video, tell me where you're slowing down. Okay. So for this, I think it's really important to look at y values, right? So I go from a speed of 0 to a speed of 2. From 0 to 2, well, I'm speeding up, right? And then I go back from 2 to 0 here. So this means that I'm slowing down. So section 3 is slowing down. But a lot of people put section 4 as slowing down. Sorry, section 5 is slowing down. But if you look at the y value, I go from 0 to -1. If I'm going from 0 to 1, I'm speeding up. So my slowing down is when I go from 1 to 0. So 3 and 7 means I'm slowing down. Okay, so just a few questions with that. Hopefully that went okay. So this is our last board question of the day. So draw a velocity versus time graph of a bullet being fired directly upwards and falling back to the ground, assuming no air resistance. So pause the video, see if you can draw just a velocity versus time graph of this situation. So if we're doing a velocity versus time graph, this is 0, this is fast, this is fast, right? So our bullet goes up, and then it goes down like that. So when it leaves the gun, it's going super fast, right? That's the fastest, and it's going up. So we're going to start up here. That's where we want to start. And then here, at its highest point, its speed is 0. So we want to go here. And all throughout this, our acceleration is 9.81 meters per second squared, right? We drew that onto our vector diagrams yesterday. So no matter where we are, our acceleration is 9.81 meters per second squared. Anytime we're near the Earth, our acceleration is 9.81 meters per second squared. So my slope is going to be like this, and it's going to be constant, and my slope is going to equal 9.81 meters per second squared. Okay. Then on the way down, here it stopped, and then here it's going fast again, right? But it's going fast downwards. So this is upwards, this is downwards. So this would be fast downwards. And what's my acceleration the whole time? Well, it's still 9.81, negative 9.81, like that, downwards. So my slope actually doesn't change. It's just one constant line like that. It kind of looks curved there. Let me just fix this. There we go. It still looks kind of curved, but it should just be a steady slope because my slope is always 9.81. That's my acceleration. I go from fast to stopped to fast. And then if I wanted to find my displacement, I would find this area, and I'd find this area, and my displacement is 0 because this area should equal this area. So the last thing we're going to talk about is instantaneous velocity. So if the speed is changing on a d versus t graph, we get a curved line. Speeds equal slope, and slope can't be found with curved lines, right? We need a straight line to find the slope. So in order to find the speed from a curved line, we have to draw on a tangent line. And a tangent line is a line that touches a curve at only one point. So you can see that this is our curved line. We're slowing down going forwards. And this is our tangent line right here. So our tangent line just touches it at one point. So we can do this. So if this was our curved line and it said, find the object's velocity at 1 second, right? And this is a d versus t graph. Well, we need to find slope at 1 second, but you can see it's a curved line, so we can't find slope. So what we need to do is we need to draw in a tangent line, and your tangent line should be like, so it should have equal area here and equal area here, but that's what your tangent line would look like. So now we have a tangent line. Well, we can find the slope of this tangent line. So this is my point number 2. and this will be my point number 1. So I just have to go y2 minus y1 over x2 minus x1. y2 is 1, 2, 3, 4, 5, 6. So 6, and this is meters, because it's a distance time graph, minus 1, 2, 2 meters, and then this is 4 seconds minus 1 second. So we end up getting 4 over 3, so we end up getting 1.333 repeated. We'll just go to 2 sig digs meters per second. So at that exact point of 1 second, right where a tangent line hits, we're going 1.3 meters per second. If I wanted to find it at 2 seconds, well, I draw on a different tangent line that's steeper, and you'd get a different one. So this only works, this is the instantaneous velocity, because this is the instant, at that instant of 1 second, that's how fast we're going. Okay, this is our homework, so we're done the unit. So D versus T graphs with acceleration are here, V versus T graphs with acceleration are here, and this is a unit review. All the answers are on these pages, so you can check your answers, and make sure you only do the ones that I assigned, because there are some bad ones in there, like 7 and 9, and then 1 isn't that good either, so try those out.